Here's a video showing the solutions to this week's problem set. In the first problem, you were asked to go to our StatCrunch group, open the cereal brand data set, and make a histogram of the variable fiber. And so I've done that here and inserted it in the document. What shape does this histogram have? So we can see that this is skewed. And if you think about the toes of your feet, this resembles your right foot. So this is skewed right. So based on the shape, what statistics should you use to describe the center or typical value and this variation or spread of the data? State the name of the statistics that should be used and the value for each. Okay, so because this data is skewed, we're going to use the median to describe the typical value. And we're going to use the IQR to describe the spread or the variation. All right, so let me take a moment, because I forgot to do this, let me take a moment and use StatCrunch to find these values. And again, there are videos, I think, in our notes of how to do this, if you're not sure how to do this, okay? But we're going to find the median, and we're going to find the IQR. And again, we'll do this using StatCrunch. And so the median turns out to be 2. So the typical cereal has about 2 grams of fiber, and the IQR coincidentally also turns out to be 2. All right, that's number 1. Number 2, when data is symmetric, what statistic should be used to describe the center, and what statistic should be used to describe the spread? So with symmetric data, we describe the center, or the typical value, using the mean, and we describe the spread, or the variation, using the standard deviation. It wouldn't be appropriate to use the mean or standard deviation to describe the fiber variable because it's skewed. The next one. In the cereal data, the amount of carbohydrates in the cereals is fairly symmetric, with a mean of 14.8 and a standard deviation of 3.9. Rice Chex cereal contains the greatest number of carbohydrates at 23 grams. First, find the z-score associated with 23 grams of carbohydrates. So the formula for the z-score, and this is pretty much the only formula that we've encountered so far that we actually have to compute by ourselves. StatCrunch doesn't do z-scores for us. You take the number, you subtract the mean, and then you divide it by the standard deviation. In symbols, that looks like x minus the mean, that's a symbol for mean, divided by the standard deviation. So let's go ahead and do that. So our number is 23. We're going to subtract the mean, which is 14.8, and then we're going to divide it by the standard deviation, which is 3.9. So let me grab a calculator and do this for us. 23 minus 14.8 equals, and then we're going to divide it by 3.9. We get a z-score of, oops, I did that wrong. Let me try that again. You have to always check that you're entering the right numbers in your calculator, so that's better. Divide it by 3.9. All right, so we get a z-score of 2.1. Based on your z-score, would this be considered unusually high, an unusually high amount of carbohydrates? Well, in your notes, we learned that one way of determining if something's unusually high is to compute a z-score, and any z-score that's greater than 2 or less than negative 2 can be considered unusual. So what did we get? We got a z-score of 2.1, which is greater than 2, so we can say, yeah, that would be kind of unusual. If you're wondering why, just as a reminder, data which is fairly symmetric might look like this, okay? We have something called the empirical rule. And what the empirical rule says is, if we were to draw a smoother picture, I'm just going to draw a smoother picture, all right? If here is our mean, if we go out 2 standard deviations to the right and 2 standard deviations to the left, we'll have found 95% of our data. Now remember, z-scores keep track of how many standard deviations you are away from the mean. So this would be a z-score of negative 2, and this would be a z-score of positive 2. 2 below and 2 above your mean. And so anything out here and anything out here would be unusual. This would be unusually low because only 2.5% of the data would be in that region. And this would be unusually high because only 2.5% would be in that region. So if your z-score is beyond 2 or beyond -2, you're in the either top 2.5% or the bottom 2.5%. So that is an unusual kind of elite place to be. Last problem. In the serial data, you saw that fiber was skewed, and here are some statistics for fiber that are given. All right. Explain why it would be inappropriate to use a z-score to determine if 14 grams should be considered an outlier. We only use z-scores if data is symmetric and unimodal. Okay, so because the data is skewed, we shouldn't use a z-score. So it would be inappropriate because the data is skewed. So instead, we use a method called the 1.5 IQR method, and I always draw a picture of this, okay? So here's the idea. Here's Q3, our third quartile. Here's Q1, our first quartile. And there are two values which are called the fences, the upper fence and the lower fence. And the location of these fences are 1.5 IQRs away from Q3 and 1.5 IQRs away from or below Q1. And so to determine if 14 is an outlier, we have to find the location of this upper fence. Okay, so first of all, let's find the IQR. The IQR, remember, is Q3 minus Q1. And so given this information, we can see that the IQR would be 3 minus 1, or in other words, 2. So where is this fence located? Q3, remember, is 3. So we're going to take 3 plus 1.5 IQRs. In other words, 3 plus 1.5 times 2. If you work this out, you can use a calculator if you'd like. That comes out to be 6. So the location of this upper fence is the number 6. So anything out here is going to be considered unusually high. Notice that 14 is greater than 6. 14 is out here in the region we would be considering unusually high. And so the answer to this is yes, we should consider it an outlier. As always, if you have any questions about this problem set, feel free to contact me and we can definitely go over it together.